Okay, today we are going to learn about how to solve what we call 3 by 3 systems of equations. A 3 by 3 system means that there are 3 variables used and 3 equations. So you can see that all of these in example 1 fit this mold. Now, the steps for solving a 3 by 3 system is first, we need to either use substitution or elimination to get ourselves down to where it's a 2 by 2 system. So we basically need to get rid of one of the variables by either substituting or eliminating. We're going to then solve that 2 by 2 system because that'll give us the answers for 2 of our variables. So we might know what x and y are, or we might know what x and z are, or y and z, but we'll know 2 of the 3 values for our variables. And so then once we've done that, we can plug those values into one of the original equations and solve for the third. We always list our answer as an ordered triple. So on 2 by 2s, I had you list your answer as an ordered pair. Here, we're in an ordered triple. The variables should always be in alphabetical order. So if for some reason we're using something other than x, y, and z, you should list it in alphabetical order. So, as I look at example 1a, again, my first objective is to get down to where I have a 2 by 2. So 2 equations that only have 2 of the variables. Now, how we do that is going to vary each time. You have to kind of look at the individual system and determine maybe the best course of action. There isn't necessarily one right answer to that either. You might have done a little more work than someone else, but you could still get the right answer. On example 1a, the first thing that I notice is that this second equation only has 2 variables already. So if it already has only 2 variables, sorry, I got to show the colors on the font. Otherwise, it won't show up. So this equation right here, it already only has 2 variables. It has just the x and the y. So if I could use my other 2 equations to eliminate the z and have a second equation that only had x and y, I would already be finished with step 1. So that's what I'm going to do. So I'm going to look at just equations 1 and 3 and try to eliminate z. Because if I can get rid of z, then I'll have 2 systems with 2 variables, or 2 equations with 2 variables. So as I look at this, if I want to get rid of z, I need these coefficients to be opposite. Right now I've got positive 5 and negative 3, which means if I want to find the least common denominator, if I had denominators of 5 and 3, the LCD would be 15. So I want these to say 15z and negative 15z. So that means I'm going to multiply equation 1 by 3. And the way that I usually note that is like I tell myself the equation number in a circle and 3 times it on the outside. So 3 times 2x is 6x. 3 times negative 4y is negative 12y. 3 times 5z is 15z. And 3 times negative 33 is negative 99. So if this one has a 15z, I need the bottom one to have negative 15z. It's already negative, so I just need to multiply by 5. So I'm going to do 5 times equation 3. So that gives me negative 10x plus 10y minus 15z equals 19 times 5 is going to be 5 short of 100, so 95. And now, because what I'm using is elimination here, now that these are opposites, I can add straight down in the columns. I get negative 4x minus 2y, the z's cancel, equals negative 4. So once I have that done, I have obtained a 2 by 2 system. Now I need to solve that 2 by 2 system. So I'm going to kind of color code. So step 1 was in red. Step 2, when I'm solving the 2 by 2 system, first thing I'm going to do is line them up underneath each other. I almost always use elimination when they're lined up like this. we did an example in class where we used some substitution. So if you prefer substitution, that is totally fine. I just gravitate toward the elimination here. So if I look at these and I'm trying to solve this system, I see that the x's already are opposites, so I don't even need to multiply by anything. Here in step 2, I can just go straight to adding. The x's cancel. I get negative 3y equals negative 9. Divide both sides by negative 3, and I find that y is 3. So I'm not done solving the 2 by 2 system because I only have one of the variables. To find the other, remember I need to plug this y equals 3 into one of these 2 by 2 equations. I'll use this one since it doesn't have to multiply by anything. So 4x minus 3, since y is 3, equals negative 4. Oops. I totally wrote the wrong one. I wrote the one from above. Don't do that. So negative 5 was this equation that I was using. So now add 3 to both sides. Negative 5 plus 3 is negative 2. 4x equals negative 2. It's not going to come out evenly. That's okay. So I definitely write out this next step so I can see my fraction. Negative 2/4 reduces, so that's negative 1/2. So x is negative 1/2. I have reached the end of step 2. I've solved the 2 by 2 system. So now I'm going to change colors again and go to step 3, which is to plug those answers from my 2 by 2, y equals 3 and x equals negative 1/2, into one of my original equations. It needs to be one, I should indicate, it has to be one that has all 3 variables, because some of them don't. So pick one of the ones that has all 3 variables. So I could go top here, or I could go bottom. Doesn't really matter. I'll probably pick the top since it has fewer negatives on the left side, but it does not matter. So 2 times negative 1/2 is what I substitute in for x, minus 4 times 3, which is y, plus 5z equals negative 33. So 2 times negative 1/2 is negative 1. Minus 12 is negative 13, so I've got negative 13 plus 5z equals negative 33. Add the 13 to both sides. I get 5z equals negative 20, which means z is negative 4. So ordered triple, negative 1/2, comma 3, comma negative 4. Now, before you put your box around it, you need to check to make sure it works. Plug these values for x, y, and z into all of those equations and make sure that you get true statements. If you don't, then you didn't do something right. I already checked that, and it does work. I did do it correctly. Yay for me. All right, I'm just going to draw a line of separation. If you write like super, super big, you might need a separate sheet of paper if you can't write small enough to fit it. But I write pretty big, so usually if I can fit it, you can fit it. All right, so next example. This one's different because I don't have this pop out at me already has one of the variables eliminated. So when I go to do step 1 here, to obtain a 2 by 2 system. This is going to be like what I call the playoff system. So you're going to look at these and you're going to look at all 3 variables and decide which one would be the easiest to get rid of. Remember that you're looking, same as the steps that I taught in substitution and elimination, you're looking for coefficients of 1 or negative 1 because those are going to be the easiest. And if I look at x, y, and z, z appears to be the easiest because I've got a coefficient of negative 1 and a coefficient of 1. So that's going to be the least amount of work, is to choose z to eliminate. So if I'm going to eliminate z, I respectfully request that you tell me what you're choosing. It helps me to give you partial credit. No, I'm not going to like take off points if you forget, but again, if I don't know what you're doing, the likelihood that you receive partial credit is less. So I'm going to eliminate z, and first you're going to pick 2 equations. So This is like a bracket for like the NCAA tournament or any type of tournament, really. So what I'm doing with this bracket is these two are going to play first because they looked like the easiest to get rid of z. So I write to myself that I'm using equation 1 and equation 2. I don't have to multiply them by anything because they already have opposites here. So if I'm using equation 1 and equation 2, all I'm going to do here is add straight down in my columns because that will eliminate my z's. So I'm just copying them, and then I'm going to eliminate the z's. So add, and I get 3x plus 4y. The z's go away. Negative 11 plus 1 is negative 10. All right, so this guy right here is like the winner from that lovely first round of the NCAA tournament. So 3x plus 4y equals negative 10. Now, in a tournament, the same two people don't play again. They've already played. So this is still part of step 1, but I only have one equation that has two variables. I need another one. So I need to choose another two teams to play and eliminate z. You have to choose the same variable to get rid of. So if I'm doing this here, I would then choose equation 1 and equation 3. Now again, if you choose equation 2 and equation 3, that's perfectly fine. But the reason I'm going with 1 and 3 is because 1's already a negative, and it's much easier to multiply by positive numbers. So I'm choosing equation 1 and equation 3. In order to get rid of z, I need this guy to be negative 3. So I have to multiply by 3. So I'm going to do 3 times equation 1 with equation 3 just as it is. So that's my little notation. 3 times equation 1 and equation 3 just as it is. So 3 times equation 1. Remember to distribute to all of the terms. So 3x plus 9y minus 3z equals negative 33. Equation 3 was coming just as it was. So I'm going to recopy it. And then add to eliminate my z's. So that gives me 8x plus 7y equals, I can't get my equals sign out, negative 12. All right, so in this playoff game, the winner was 8x plus 7y equals negative 12. Sorry, my equal signs sometimes end up looking more like some weird scratch notation that I'm not even sure what it looks like. Okay, so once I have that, now I'm done with step 1. I obtained a 2x2 system by my playoff system here. So now I need to solve that 2x2 system. So I'm going to try to keep the same color. I'm going to do that in blue. I did the 2 steps here in 2 separate colors. So in blue, I'm going to solve the system of these 2 equations. Now, again, I prefer elimination. You can use substitution if you want, but I need to get opposites on these coefficients, either on the x's or on the y's. One does not look easier here than the other, so it doesn't really matter. It's going to be about the same amount of work no matter which one you choose. So I'm just going to go with the x's since they're first. The least common denominator between 8 and 3 is 24. So 8 times 3 gives me 24, so I'm going to multiply this guy by 3. So that gives me 24x plus 21y equals negative 36. Down here, if this was positive 24, I need the bottom one to say negative 24. So I'm going to multiply by negative 8. So that gives me negative 24x. Negative 8 times 4y is negative 32y equals, better equal sign that time, equals 80. So now add straight down because I've got the opposites here. So 21y and negative 32y gives us negative 11y. Sorry, that doesn't look like a negative 11 or a y. Don't know what's up with my handwriting today. 80 minus 36 gives me 44. So negative 11 is what I need to divide by on both sides. 44 divided by negative 11 is negative 4, so y equals negative 4. Once I know what y is, when I go back to plug it into this round of the tournament. So these ones are smaller numbers. I would probably plug it into the top one. So 3x plus 4 times negative 4 equals negative 10. So that gives me 3x minus 16 equals negative 10. Add the 16, that gives me 3x equals 6, so x equals 2. So I've got y equals negative 4, x equals 2. The 2 by 2 system is solved. Step 2, check, done. Step 3, plug those answers into one of my original equations, making sure they have all three variables. All three of these do have all three variables. Again, doesn't matter which original you choose. I would probably pick the second one because the numbers are smaller, but again, your choice, what you want to choose. So I'm going to do 2 times x, which is 2, plus y, so plus negative 4 is the same as minus 4, plus z equals 1. So this is 4 minus 4, which is 0. So 0 plus z is z, so z equals 1 is my solution for z. My ordered triple then, x is 2, y is negative 4, z is positive 1. Again, please plug these in. 2 minus 12 would be negative 10. Minus 1 is negative 11, so it works. 4 minus 4 is 0, plus 1 is 1. 5 times 2 is 10. 10 plus 8 is 18. Plus 3 is 21. So I have checked it. I know that it's correct. I'm good to go on it. All right. Last one, C. So again, I've got all three variables in all three equations. So I'm going to kind of look at it and decide maybe what my best course of action might be in order to eliminate one of the variables. I can see a case really for all of them. They're about equal. These ones have two coefficients of 1. So that seems appealing because I would just have to multiply by a negative. But these are already the same, which means, again, you'd only have to multiply by a negative. They're all pretty relatively easy in this case. So that doesn't necessarily matter all that much what you're going to choose. So I am going to go ahead and choose equation 1 and equation 2, and I'm going to go ahead and eliminate the z. So here's going to be, oops, forgot to switch my color. Here's going to be that bracket here. And so I'm going to choose equation 1 with negative 1 times equation 2. So equation 1 was negative x plus 2y plus z equals 3. Equation 2, when I multiply it by negative 1, becomes negative 2x minus 2y minus z equals negative 5. So everything multiplied by negative 1. So now add them. Negative x plus negative 2x is negative 3x. Unexpected result here. My y's drop out too, along with my z's. And that gives me equals negative 2. Divide both sides by negative 3. And x equals 2/3. Now, when this happens, you should be excited because it means it's going to be a little bit less work. So on this playoff system, I didn't get a 2 by 2 equation. I actually found a value of x. So that means when I go to do my second playoff, that I should be able to solve the 2 by 2 right away by plugging in this 2/3. So in my second playoff, I'm going to do equation 2 and equation 3 here. And again, you have to eliminate the same variable, so I eliminated z originally, so I'm going to go for z here, which means this would need to become negative 2z. So I'm going to do negative 2 times equation 2 with equation 3. So negative 2 times equation 2, we got to distribute it to everything. So negative 4x minus 4y minus 2z equals negative 10. And then equation 3 staying just as it was. Okay, now I add straight down in the columns because I'm trying to get a 2 by 2. Uh-oh, x's cancel, y's cancel, z's cancel. That gives me 0. On the right side, I get negative 4. This, again, should be cause for celebration. Hopefully you recognize this from the 2 by 2 systems. When all your variables drop out and what is left is a false statement, you can stop what you're doing. You do not have to do the rest of the steps. When this happens, and of course check to make sure that you actually did the steps that got you that correctly. But when this happens, since 0 does not equal negative 4, that means that this 3 by 3 system has no solution. There is no ordered triple that can satisfy all 3 of those equations. Now remember, if the variables drop out and it's a true statement, like 0 equals 0, then that would be infinitely many solutions if that happens. Now, let's say that you hadn't picked 2 and 3. Let's say that you picked 1 and 3. If you picked 1 and 3 instead, you might not get them all to drop out. But what might happen is you get x equals something else. In a 3 by 3, if most of the variables drop out but you get conflicting information, then that means that's also a no solution. Normally, if that happens, I pick the third playoff pair just to double check. I happen to pick the right one here, so I know that my answer is no solution. All right, big thing here. Please do not get discouraged if you think your answer is wrong. Do not erase it. Just keep going. I'm looking for the steps and I'm looking for the work that you tried. So the rest of them are up to you to solve. You can see there's 4 of them. So don't get discouraged. Just keep going anyway. It might be 95% correct. You just made a tiny little addition error. So don't get frustrated. Everybody makes mistakes on these. You could miss every single problem and still have an A on the paper because your mistakes were so slight. So please don't get discouraged. There's a lot of little places to make errors. Have a good one.